whatever was there will be there. When it is 0, 1, it is a reset condition. So whatever will be there in the present state will be reset to 0. Then there will be input will be 1 and 0. The next will be 1. That is the state. And 1 is invalid condition or forbidden condition, which we have already discussed. Now you can see here. So now the excitation table, you can see here you have to write like this. So in present state is Q1, next state is Q1 plus 1. Okay. So now there will be the requirement of required input. As you can see here 0, 0. So 0 to 0, that means present state to next state. So you have to write like this for obtaining the conversion of flip-flop. This is the first step which you need to understand. So when it is 0, 0, so you have to keep in mind that it can be achieved by two conditions. Either there will be no change or there will be reset. Okay, so you can see here either it will be 0, 0, okay, or there will be 0, 1. In other words, it has to be 0, don't care. Because you know don't care condition can take any of the value, either it can be 0 or it can be 1. So we have to write down 0, don't care. So next is 0, 1. Similarly, 0 to 1 can be achieved only using set condition, and that is S is equal to 1, R is equal to 0. 1 to 0 can be achieved using reset condition. So it is now 0, and here in the place of R there is 1. From 1 to 1, it can be either no change, that is 0, 0, or it can be set, that is 1, 0. So in this condition it will be don't care 0. Either it is 1 or it is 0, whatever it will be there in S. And if R is 0, next state is bound to become 1. Okay, if Q1 is 1. Now excitation table of JK flip-flop. As you can see here, this is the characteristic table of JK flip-flop. So you can see here from Z to it obeys the same as a SR flip-flop. Only the exception is the 1-1 situation, which was invalid in SR flip-flop and overcome in JK flip-flop. And the mode was toggling for 1-1 condition. The same is going around here. Okay. So you can see here, if J and K is 0, 0, it will be the same Qn, no change. Where it will be 0, 1, it will be, you can see here, reset 0. When it will be 1, 0, it will be set 1. And when it will be 1 to 1, it will be toggling, as we have seen while we were discussing the basic of the JK flip-flop. Okay, so it will be Q1 bar. So Q1 plus 1 is equal to Q1 bar. Okay. Now let us see the excitation table. Present state, next state, required input JK. As you can see here, now we will go into 0 to 0. Okay, 0 to 0 can be obtained either no change or reset. So it can be 0, 0 or 0, 1. So it will be 0, don't care. Okay, 0 to 1 can be achieved by, now in JK flip-flop we have this stable state. Okay, we have this rather I will say valid state, because anyhow toggling will be somewhere around we have to overcome if, because in toggling what happens is sometimes it becomes unpredictable due to the delay of the clock. So it's better to rather coin it as a valid state which was overcome in SR flip-flop rather than straight away going for the stable state. So therefore, anyhow, so when it will be from 0 to 1, okay, from 0 to 1, here you can see it can either be toggling. Okay, toggling we know that it just reverses the state. So if there is 0, next it will be 1. Even it can come, even this can be achieved by sets input. Okay, so either it can be 1 1. Okay, I'm sorry here, JK. So either it can be 1 1, that is toggling condition, so that 0 will become 1, or it can be 1 0, so that it becomes set, anyhow it becomes 1. So that means we can write down 1, don't care. This input can either take 1 or 0. Okay. Now 1 to 0. Okay. 1 to 0 can be obtained either by rigid condition or toggling. Okay. So either it can be 1 1 or it can be 0 1. So that means 1. 1 to 1. So either it can be 1 0 set or it can be 0 0 no change, as you can see here. So 0 0 1 0. Don't care 0. Okay. You don't care this input for this condition. Okay. Now let us start the conversion of flip-flops. Okay. As you can see here, this is the input of required flip-flop. The combination circuit will be there, and we need to convert from one flip-flop to another. So that means we will be having a unknown flip-flop. Okay, we will be having rather whatever flip-flop we will be having in our hand, and we need to convert it to the desired flip-flop. Okay, so this is the block diagram representation of our situation. Now the methodology, how we will be able to do that. We are having certain flip-flop in our hand, and we need to find the characteristic of some other flip-flop using that particular flip-flop. Okay. So what is the methodology behind? So you can see here, the first step of conversion is that write the present and the next state table, that is characteristic table of the required flip-flop. In the table, for each transition Q1 to Q1 plus 1, write the values of required inputs of given flip-flop. For this excitation table of given flip-flop should be referred. Draw K-map for each of the input variable of given flip-flop in terms of present state and inputs of required flip-flop. From the K-map, obtain the simplified expression of each of the input of the given flip-flop. Now, design a combinational circuit for the above obtained expression and connect this with given flip-flop in a correct manner. So that means you need to know the characteristic table of both the flip-flop, that means which is there in your hand and which you need to convert. Then you have to find out the whole table as we have seen just now. Okay, that is, you have to find the excitation table. Then based on that state, we need to obtain the K-map expression, the simplified expression using K-map, and then we need to fit the circuit. Okay. So let us see one of the first example, that is conversion of SR flip-flop to T flip-flop. Okay. Conversion of SR flip-flop to T flip-flop. One thing which should always be visualized in our mind whenever we are talking of conversion is that which flip-flop to which flip-flop. Okay. So SR flip-flop to T flip-flop. So after conversion, now input has to be a T flip-flop. And given flip-flop in our hand is the SR flip-flop. Okay. So for that purpose, we need to have the, first of all, the present state and the next state table of T flip-flop. So now, as you can see here, when T is 0, okay, then what will happen? If Q1 is 0, Q1 plus 1 is 0. Okay. Because T flip-flop works only in two modes. Either when T is 0, it is a no change condition, nothing will change. Whatever will be the present state and the next state will remain same. Okay. Or if T is 1, because it is a shorted JK, when T is 1, toggling will occur, then Q1 plus 1 is equal to Q1 bar. So therefore we are pretty okay with this particular flip-flop. So 0 becomes 0 only. But if here is 1, then toggling will occur. Okay. Same, toggling will occur, 0, no change. So this is what our T flip-flop does, or the conversion table. Okay, as you can see here, external input, as I told you, T This is the present state and the next state. Put it here. And this is the flip-flop input S and R. How we have obtained that? You see here. Now, after obtaining this particular this much, okay, forget about this one. Forget about this one. Okay. See here. See, now you get this one. From 0 to 0, 0, don't get. 1 to 0, 0, 1. 0 to 1, 1, 0. 1 to 1, or don't care 0. Okay. Now this is, if you put that, okay, if you put that, now this is the K-map for S. Okay, so you can see here 0 0 1 0 0 0 1 1 0 1 1, and you get all these input. Okay, so likewise you will get the K-map for S, T, Q, and bar, and likewise you will get the K-map for R as T, Q, N. Okay, as you can see here. Then desired conversion of SR to flip-flop can be got like this. Okay, as you can see here, in this S, because we were having this flip-flop in our hand, we need to convert this into T, and we get S is equal to T, Q, and bar. So it's a AND gate. As you can see here, so we have connected one AND. This is Q and bar, and this is T, isn't it? T, Q, and bar. You can see here. Similarly for R, we have got T, Q, N. So T, Q, N. Now you see this flip-flop, the T input will work. Okay, and we using this methodology, we can successfully convert SR flip-flop to T flip-flop. Okay. Now the next case is conversion of JK flip-flop to D flip-flop. Now present state and next state table of JK flip-flop. We have already discussed this in length. 0 to 0, no change. 0 to 0, no change. 0 to 1, you can see here, it will be reset, 0 0. 1 to 0, 1 to 0 is nothing but it is either toggling, you can see here 1 to 0. So it is nothing but if Q1 is 0, then it will be set to 1, and 1 to 0, if Q1 is 1, okay, it is still 1 because it is set condition. Okay, whereas 1 to 1, 1 to 1, when Q1 is 0, it will be toggling 1, and when Q1 is 1, it will be toggling 0. Okay, so this is the present state and the next state table. Now we will talk about the conversion table. Okay, so we have got this one. Now we will see the behavior of D with respect to this present state and next state. So 0 to 0, 0 to 0 means no change. And we know in case of D flip-flop, what happens is D flip-flop is having only two changes, okay, or other two conditions, or other two exceptions. What? Either there will be no change. Okay. Either if if D is 1, then you will get S as 1, R as 0, because there will be inverter in the middle. Okay. And if D is, so in case of D flip-flop, what will happen? We have seen that in case of D flip-flop, there will be input D over here, okay, and in the middle we will be having one inverter like this, okay, inverter like this. Now this is the common clock. So this is how and this is the latch part. Okay. But we are interested here. So if we are putting here 1 as input, what will happen? Here will be 1 and here will be 0. Whereas if we are putting here 0 as input, here will be 0 and here will be 1. So when there will be 1 input, it will be 1 0. That means S1 R0. It is set. And when there is 0 input, it will be 0 and 1. That is reset. So therefore I told that if 0 to 0 condition is there, D has to be 0. Okay? Because in D0, we are having a reset condition always. From 1 to 1, D will become 1 set condition, and similarly for other of the cases. Now we will go for the K-map. Now this is the K-map for D, and we are getting D is equal to JQN bar plus QN K bar. As you can see here, this is a circuit. Now we are having this we are having this this is basically JK. Now result conversion from JK flip flop to D flip flop. Okay. So this is how we get it. Okay. Now we will convert P flip flop to T flip flop. As you can see here, present state and next state table of T flip flop is this one. We have talked this, and this is the conversion table. Okay, D flip flop to T flip flop. Okay. So similarly, we will be getting the K map for D. We are getting this T XOR of Q1, and now this is how we see here. Now we are getting this T from D. Now T to D. Similarly, we have discussed this about D. The conversion table is this one, as you can see here. This is the conversion table. So D to T, to D to T, similarly like others. Now this is the required K map. The same procedure for all. Very simple. And you see, using T, we get D. Because T is equal to D XOR of Q1. Okay. So D XOR of Q1. Thank you.